Hello guys, thank you for watching this video, and we are going to continue with our second week and more definitions that I think is really important to understand and know. And okay, let's do it. What is the goal of this week course? Our goals is to get the formula of the zero order language. Once again, is to get the formula of the zero order language. Can you explain in your own words what is a zero order language? Let's review once again. The zero order language is represented with L, then 0, and then equals, we open this kind of brackets, LC with R the logical constant, then the non-logical constants, and the form. Once again, our goal, what is our goal? Is to get formulas or formula in the zero order language. Okay, so let me give you one example of this. If we put here L and we put the number 1, what does mean if I put the number 1? Well, that means that it's one special order language, but it's part of the zero order language. Okay, so I'm going to put here logical constants, and inside of the non-logical constants I'm going to make one special contain. This is special contain, it will be the P and the Q. This is my, at the beginning, my non-logical constants, and as well comma and form. This is one special language. Now I'm going to put another special language with L and 2. With L2 I open my brackets and I put like always the logical constants, and then in the I'm so sorry about my parentheses. In the non-logical constants here I'm going to put the P, then the Q, and then the R. I'm closing this part, and by the end the form, close it back brackets. What is the difference between this special language 1 and this special language 2? Well, the only difference is that here in the special language 2 or L2 there are more elements in the non-logical constants, which are P, Q, and R. And in L1 we have just 2, which is P and Q. Okay, so there's not a big deal, but this is really useful because the theory will say that the non-logical constants, which represent this CON, non-logical constant, are the subset of the form. Okay, in other words, we can say that P, which is here, and Q belongs to a form or are part to the form. By the other hand, P, which is in L2, Q and R belongs to a form. That means, in my words, and I hope that you can understand the way that I understand, that with these elements of the non-logical constants, you can create many things. When I say create, I'm saying like if you have P here, you can negate this P. Put in an example, negation P, and even there is a logical constant negation and the non-logical constants P, this also can be part of the form. As well, if we put negation P, this continue be part or belongs to a form or is part of the form set. Let's put a really strange situation. What if I put negation P 3 times? What happened? Is this part of the form? Yes, it is. So this is part of the form. And as well in this case, so we can make some operations or make formulas, which is our goal. Okay, so an example, if I put a, let's say I'm going to put the Q and I'm going to create one formula. And this formula, let's say that Q is the implication of negation R. And remember to close. My question for you is this a formula? Yes or no? Yes, it is. This is belong to a form. And what if we start to negate this? If we put negation, we open this parenthesis, Q implication negation R. Is this a formula? Yes or no? Yes, it is. This belongs to a form, which is part of the language. Once again, there's no difference. There's just more elements in L2. Now, let's clarify this. What if we put an example, another special language? I'm going to write down L3. L3 is equals to the logical constants, and in the non-logical constants I'm going to create the A and the B. I close it, and the forms. We are going to make some special language, and our goal is to find forms, I'm sorry. So what if I put negation A implication negation B? Is this a part or is this a formula? No, it's not, because it's really important to put the parentheses. If we write in a different way, parentheses, then negation A implication negation B, and we close, this is part of the form, and this is not part of the form, or this is not a formula, but this is a formula. One last example. Let's say that we put A, then conjunction B, implication A. My question is this a correct formula? How can you know that this is a formula or is not part of the formula? Well, it's really difficult, because where can we start to make the direct sub-formulas? Let's try. Let's put here one line, and let's try an example. A, then conjunction B, and the another one A. Well, here we have a formula, so this is correct. This is correct, but this is not correct because they don't have parentheses. So this is not a part of the form, and here it's part of the form. So let's check the another side. If we start with the A, we say that this is a formula. But what if I just put B implication A? Is this a formula? No, that not belong to a form. By the end, we say that